Today I'm launching my beginner course called iOS Dev Launchpad. Now, I wanted my beginner course to be different, right? Because I know there's a lot of beginner courses out there. And of course, we're gonna do the basics of the Swift language. We're gonna learn all about Xcode. We're gonna build a couple beginner apps. Like, of course, we're going to do that. But my idea or my goal, my mindset, whatever you want to call it, for this course was to be like, imagine if you had a really good friend who was an experienced iOS developer, and you went up to them and you were like, "Hey, friend, I want to be an iOS developer too. Can you teach me? Can you show me the ropes?" So when I built this course, I built it through that lens. And that's why, yeah, again, of course, we're going to do the code, build the apps, of course, but we're also going to talk about like the world of iOS development. And that includes things like the various career paths you can take, the pros and cons of each, things like what are third-party libraries, like what is version control, how do apps even work with like the server and the client, and like what is an API. We're also talking about how to network as a developer. What are blogs you should be following? What are recommended podcasts, recommended books? Because I know what it's like to start something like this. You're just a ball of excitement and enthusiasm. And my goal with this course is to point that enthusiasm rocket in the right direction so that your journey is a lot smoother, right? Give you a great foundation, point you in the right direction, and you're good to go. So that's the overall idea for the course. Now let's talk about some details in what you're going to be learning. First of all, who is this course for? I built this course in mind for the absolute beginner. Like, we start from the beginning, how to download Xcode. This is what a variable is. This is what the Swift language even is. Like, we start from the very beginning. That being said, if you're still early in your journey, like, there's almost 60 videos in this course. So I'm confident that even if you're past that absolute beginner, but you're still early, I'm confident you'll still get value from this course. But again, I designed it so that you could easily pass this off as somebody's very first steps into this world, right? Again, like, you have a friend that says, "Hey, I want to learn that too." Like, this is the content you give them. And because this is meant for absolute beginners or those that are very early in their journey, I keep things at a high level. This course is all about just exposing you to this world and building that foundation, because this is the first step among many. But also because, again, I remember what that was like. This is how I learned, by doing online courses, YouTube videos. This is how I started my career. So I remember being completely overwhelmed. So there's a lot of topics that I could have gone deeper into and given you a ton of information. But what I'm trying to do with this course is walk a fine line between giving you enough information, but not giving you too much to where you're overwhelmed or it's confusing, and you just kind of give up, right? So I'm trying to walk that balance. So I know some of you may say, "Oh, I wish you would have went deeper in that," or maybe in some topics I go too deep for you. But just know that, like I said, I'm trying to walk that balance, because I know what it's like to be overwhelmed. And sometimes getting all the information is more confusing than helpful. Because like I said, this is step one on a long journey for you. Most people that start from scratch to get hired as a professional iOS developer, it can take anywhere from 6 months to 2 years and everything in between. So don't think that you're going to take this course and be ready. Like, this is not how it works, right? This is a long journey, at least 6 months of hardcore learning, likely even longer. So I just want to set those expectations. Another thing I wanted to be sure to include with this course is good service. So I've created a Slack channel that's for all my courses, right? But each course has their own individual room. But this is a Slack channel that you can join and go in and get real-time help, not only from me, but from other students. Like I said, that Slack channel is for all my courses. So you're not just going to get beginner developers in there, you're going to get more experienced developers in there as well. And what I've seen so far is that people have been very helpful in that Slack channel. And I'm very thankful for that, because as thousands of students come into these courses, I just can't answer everybody's questions. So we're trying to build a good community to help each other out in that Slack channel. So be sure to join that. So let's finish up going over the structure of the course. So for about the first 40 to 50% of it, we're going to be going over the basics of the Swift language. Then we move on into building a couple of, basic beginner apps. We're also going to break down one of these apps where we build it the first time using Storyboard and Interface Builder, and the second time we're going to build it all programmatic UI. So you get a little taste of both. And I also have a little Swift UI preview section talking about what it is, why this is a very different way of doing things, and then we build like a little sample screen with it. But the reason this whole course doesn't focus on Swift UI is because, it was just announced in summer of 2019. It's still very early. It's going to take a long time for, major apps to adopt it. It will have its day, but it's still very early. So again, if you're trying to get a job in the next 6 months to 2 years, UIKit is still going to be very, very dominant. But we give you a little taste of Swift UI here. And then we move on to kind of like the general programming knowledge section, talking about, how apps work, the server, the client, what is an API, what are third-party libraries, how does version control work. We talk about different career paths. And then I start recommending some resources. Again, podcasts, blogs, websites, videos, books. Again, I want to set you up for future learning because this is the very first step in your journey. A little over 5 years ago, I was just like you. I was trying to learn how to code just by watching online videos, taking online courses. And I wrote my first line of code at 32 years old, had no prior programming experience, just wanted to do a career change and was interested in this. And I wanted to create a quick video in this beginner course going over my story, just to show that, again, I didn't start coding till I was 32. I had no prior programming experience, and I've done very well for myself. And I don't say that to brag. Again, the point of this video is to show you, somebody that was in your shoes and that has done it. So like I said, I've been an iOS engineer for about 5 years now, just about all of which was spent in San Francisco in Silicon Valley. How I got interested in all this is I was working for a startup out there as a growth lead, sales type stuff, and I just became friends with our engineers because it was a small team, small startup, and started asking questions about what they were doing and just about coding in general. And to be honest with you, and I hope this doesn't come off as arrogant, but after getting to know them and seeing what they did, I was like, I'm just as smart as them. There's no reason I can't do that. So I started exploring, started Googling, doing online videos, YouTube, buying online courses. Again, I was exactly where you are right now. So when I started learning, it was early 2015. By summer of 2015, I did an iOS developer bootcamp. Now I know what you may be thinking. Well, bootcamp is great. That's what gave you that head start. But now that I've done the bootcamp and I've created tutorials, you just learn the very basics in the bootcamp. Like everything I learned in the bootcamp is in super beginner online YouTube videos, right? The benefit of the bootcamp for me was forcing myself to work on it for 8 hours a day, right? Because you got to be there for 2 months, 8 hours. So that was the huge benefit of the bootcamp. Not I got crazy good knowledge or crazy good teachers. It just forced me to do it. But my bootcamp was a good experience. I liked the people I graduated with. We ended up building an app called Fit Hero, which I really, really like. You're seeing some screens of that. Thought it was pretty cool. And about a month and a half after the bootcamp, I got hired at my first real iOS developer job. So now we're talking November 2015 at a company called Breathometer. They were on Shark Tank. They were the first company to get all 5 sharks to invest. I think they got $1 million investment. This was back in 2013. That was a pretty big deal for the time. But I got that job not for my developer skills, and I'll tell a quick story. So I basically did the phone screen interview, failed miserably, did horrible. And I found out later, they're like, yeah, we put you in the no pile, we were already moving on. But what I did was I showed a little bit of initiative. I emailed them and said, hey, look, I know I didn't do well on that. Do you have a take-home project that I could do, something I could work on that I can really showcase my skills? Because I know as somebody without a CS degree and just a bootcamp grad, I know I have to prove myself even more. So I would love to do a take-home project and show you what I can do. That was basically the email. And they said, sure. And long story short, I did the project, they loved it, and I got hired. So I guess the tip there is don't be afraid to show some initiative. But anyway, I got hired there, again, in San Francisco, and I was making $60,000, which again, when you talk about salary, that is different all over the world. I get it. But for San Francisco, right, Silicon Valley, $60,000 for an engineer is well below minimum wage. But I took it because, again, I had applied to 60 companies. I wasn't getting any jobs. It was rough getting that first job. So I was like, I just need somebody to take a chance on me. I know I can get in there, prove myself, and I'll ask for a raise in 6 months. That was my plan. Because I knew I would get in there and perform. I had confidence in myself. And within a month and a half of working there, my VP of software, my boss, kind of pulled me aside and was like, I'm working on a raise for you. You deserve it. We need to pay you the just market rate. It wasn't like I was getting superstar money, but just market rate. Because 60,000 was not market rate. Long story short, a Series A funding, delayed it and delayed it and delayed it. Anyway, I ended up getting $100K by May of 2016. So I'm 6 months in to my first ever job, and I crossed the 6-figure mark. And again, I don't say this to brag. I say this to just let you know what's possible. So I worked at Breathometer for about 1.5 years, and then I left there to start interviewing at some of the major companies in Silicon Valley, right? The Facebooks, the Apples, the Googles. Naively, I thought I was ready, right? After just 1.5 years of basically on-the-job training, I thought I was ready. So I went out and did all those interviews. I got my butt kicked, basically just failed all those interviews. It was a great experience, and I did get interviews at all these companies, but when I got to a final interview or a whiteboarding session, I got my butt kicked. But it was a good rude awakening, and it actually led to the creation of my YouTube channel that many of you are probably familiar with, because I wanted to show my knowledge. Rather than wait on an interview, I wanted to just put all my knowledge out there by making videos, become a well-known name in the space, and that was kind of the whole point of the YouTube channel. But during this time of me getting my butt kicked at interviews, I picked up some contracts on the side because I had quit Bathometer. I wasn't working. I was focused solely on interviews. And as I'm getting my butt kicked in the interviews, I started picking up more and more contracts and was like, you know what? Let me try contracting, right? I got enough to support me. So for the next year and a half, I did independent contracting, which was great. I say that was like the time where I learned the most, because in independent contracting, I bounced around from project to project like every 3 or 4 months. So I got a lot of experience and a lot of exposure to different code bases, different types of apps, etc. So that's when my learning really skyrocketed. And again, at that point, I'm already a year and a half into my career before my learning skyrocketed. So just keep that in mind. So after working remotely by myself for about a year and a half, quite frankly, I started getting bored and lonely. Like I never left my apartment. So I was yearning to get back on a team. So in April of 2018, I joined Aluna, which was great because I got the opportunity to build a product and build the app from scratch. And it had like a video game element to it. So it's kind of building like, the economy of the game. Should we implement daily quests? So that was a ton of fun. And I worked there full time up until July of 2019. I'm still there to this day in more of a part-time consultancy role because I'm there to like help them make sure the app launches correctly and smoothly, but I'm not there full time anymore. Now I left Aluna back in July of 2019 because I wanted to do one of two things, right? I was kind of at like a crossroads in my career. Because I'd spent all my time either independent contracting or at small startups, I never got that experience at a big company like the Googles, the Facebooks, Apples, etc. So I really thought I wanted that on my resume. And it's not that I wanted to work at a big company, like I wanted the clout, the prestige, if you will, of having that on my resume so that could potentially open up doors for my future. So looking back on it, I kind of wanted to work there for the wrong reasons. Long story short, I could either go big company or pursue this YouTube thing full time because I've been building this YouTube channel, at this time for like 2.5 years. It was growing well. I could see the business opportunity there. So my choice was big company, do my own thing. And I was actually in pretty serious talks with PayPal. I was in the interview process with Twitch. And right in the middle of all that, I decided I'm going to pursue my own thing and do this YouTube thing full time. So that was back in August of 2019. I made the full-time leap and here we are, right? The YouTube channel is going very well. I'm putting out courses for the community, creating all kinds of content for the community. I'm very happy with my decision, right? I work for myself. I get to work on fun projects, whatever I think will help my YouTube business. It's just a blast. So I was able to take this skill that I learned, this iOS development, building products, and parlay that over 5 years into now working for myself. Again, the biggest benefit of that is I get to work on what I want to work on, right? If I have a cool idea, I work on it. And as of March of 2020, it has already surpassed my Silicon Valley developer salary, and we're still just getting started. So I don't say that to brag. I wanted to share my story just to show you how great this career is and this skill is and all the flexibility and the things you can do. Like the multiple career paths you can take with this skill, it's just amazing. In fact, I got a whole video later in the course talking about all the different paths you can take to really, fit your lifestyle. So that's my story. And again, I wanted to share that to hopefully inspire you. Of course, you're not going to follow my path directly. You're going to create your own path. But the beauty is you have so many options. That path can take you so many different places. So let's just get on to learning this stuff. Before we can actually start writing Swift code and building apps, we need the tool to do it, and that's Xcode. Xcode is a IDE, or Integrated Development Environment, which basically just means it's a software program for you to write your code. And Xcode is Apple's first-party IDE that allows you to write code for Apple's platforms, right? iOS, macOS, watchOS, etc. And the great thing about this being Apple's first-party program is that it's updated constantly. The typical release cycle, like for example, we're on Xcode 11 right now in March of 2020. But every June, the next Xcode gets announced. So Xcode 12 will get announced at WWDC this year and will be officially released, in the fall. But again, it does get updated periodically throughout the year with like Xcode 11.1, 11.2, and so forth. And here on the screen is just what Xcode looks like in a typical project. The project we're looking at right now is the code for my take-home course, and I usually have 2 files of code side by side. And if this looks a little small, that's because usually when I do a tutorial or a course, I have my font and my screen resolution blown up so it's easier for you to see. But typically when I code, it is pretty small like this. So now that you have the general idea of what Xcode even is, let's talk about downloading it. First and foremost, you're going to need a Mac, whether that's a MacBook or an iMac. You're going to need one of those because Xcode is meant to run on Mac OS. Now, of course, with anything with computing, there are hacky ways to get it to run on a PC, but that's not recommended. To download Xcode on your Mac, go ahead and open up the App Store. Now, down in the lower left, you should see your name, hopefully. That's if you already have an Apple ID. Now, again, if you already have an iPhone and a Mac, you probably have set up your Apple ID a long time ago, but just in case you haven't, go ahead and click sign in, and you have to create your own Apple ID there. If you're already signed in, you're good to go. In the upper left here, type in Xcode into the search, and you'll see it pop up. Click on Xcode to open up the detail page to, see a little bit more about it. Now, as you can see down here, it is 7.8 gigabytes download, so it is a very large file. So make sure you have enough space for it, and make sure you got about a half hour to download it, depending on your download speeds. After it's finished downloading, you should see it in your applications folder. Go ahead and double click on it to open it up, and you'll see this quick little menu screen. Now, as you can see, there's 2 paths we can take. We can create a new project or create a new playground. We'll start with a project. So opening up a project is a full-fledged, app, whether that's an iPhone app, Mac OS app, watch app, whatever. That's a full-blown app. Now, however, you may just want to play around in some code. As a matter of fact, that's what we're going to do in much of the first half of this course when I'm just explaining the basics. That's where you would open up a playground. Playground's aptly named, right? It's for you to just go in there, play around for a little bit. Think of it as kind of like a scratch pad for your code if you just want to try something out. But it can go above and beyond that. Like you can even prototype UI in a playground, and then once you got the UI tweaked the way you want it, you can just copy and paste that code into your project. So playgrounds are insanely valuable. So like I said, in this course, we're going to start with playgrounds, but once we start building apps later on, we are going to shift into projects where Xcode gets a little more complicated. And don't worry, when that time comes, I have some separate videos giving a tour of Xcode, how to use it. We'll dive into more detail on Xcode then, but I don't want to teach it to you now and have you forget it by the time we actually use it. So we'll push that off till later. But there's one thing I want to show you right now because it will affect the playground is your Xcode theme. Many of you that just opened up Xcode for the first time, you're looking at my Xcode, which has a black background, bright colors. Yours may have a white background, and you're like, wait a minute, how do I customize that? How do I get my Xcode to look like yours? Let me show you. So back in the main Xcode menu, go ahead and hit create a new Xcode project. Now see, you'll get a bunch of options here, right? WatchOS, tvOS, etc. Just open up iOS. This is just a test app. We're not really getting into it. You can call it test. We're going to delete this later. You can fill out the rest of this based on my information that I have here. Make sure you have Swift selected and Storyboard selected, not Swift UI. More on that later. Again, I'm skimming over this because we're just opening up a quick test project. We will go more in depth later on in the course. So hit next and then save it to wherever you like. I'm going to save it to my desktop. We'll replace it. I already have a test one because I do this a lot. Maybe you don't. So what I want to show you here, again, is Xcode and then preferences. So actually, let me get some code up here. Let me go to View Controller to get some code on the screen, and then Xcode preferences. And you see here, I already have it selected, fonts and colors. If you don't, that's where you want to go. And then you can see this theme here on the left. You probably have it on basic, which is a blinding white, like only psychopaths use light mode, like use dark mode. Jokes, of course. But you can see a bunch of different themes like Civic. I'm just going to, page down through these so you can see all the different themes you can choose. So pick whichever one you like. Again, I was joking. Maybe you do like the light background. Maybe you like this yellow background. But I choose Midnight. And then once you choose your theme, you can actually pick each individual aspect of that theme and customize that even further, down to the font and the color. For example, this comments by default is this same green that you see here. I like my comments, as you can see over here on the left, I like my comments to kind of fade into the background. I don't like them to be, overbearing because I like my code to actually pop, just my personal preference. So what I did was I clicked on comments, and then you can click next to the font here. You can see the color wheel will pop up, and then you can pick whatever color you want. So keep an eye on my comments here in the upper left. Like, look, I have them blue. We'll have it dark. Right? They can be blue, they can be green, yellow, red. You can make it whatever you want. Again, I I like them to just be gray so they fade into the background and not be too overbearing. So again, if you want to play with your theme to get it to look right or look like mine, this is how it's done. Have a ball, customize it the way you like, but this will affect your playgrounds that we'll get into in the next videos. Let's take a second to talk about UIKit versus SwiftUI. So UIKit is what we've used to build our user interfaces in iOS development pretty much since it came out. And SwiftUI seems to be this new direction that Apple's going for all of its future development. Now, we first even heard about SwiftUI in the summer of 2019, and it finally just came out of beta in fall of 2019, but it is still extremely early in its development. So you, as somebody just starting out in iOS development, you're probably asking, what should I learn? Should I focus on UIKit or should I focus on SwiftUI, right? Because if SwiftUI is going to be the future, like I want to focus on where Apple's going, not where it's been. And that makes sense. I get what you're saying, but let's talk about that for a second. The bottom line is with SwiftUI, again, it's super early in its development. It's not going to be relevant in the job market for a couple years. And by relevant, I'm not saying there's going to be no SwiftUI jobs. I'm saying that like a large chunk of jobs will be SwiftUI. And I think that's still 2, 3, 4 years away. And the typical time frame it takes for someone like you who's just learning iOS development to get that very first job, that can take 6 months to 18 months to even 2 years, right? Like that's the typical time frame. So this course is coming out in March of 2020. I would say 2 years from now, SwiftUI will just be starting to kind of hit its stride. But let's think about this for a second. The App Store has been out for 10 years. And the way we've made apps up till now is with UIKit. So that is millions of iOS apps built in UIKit. But even next year, 2, 3, 4 years from now, when you're out in the job market, there's still an extremely high likelihood that the app you get hired for will be either all UIKit or still have a lot of UIKit. So the bottom line is, you're asking yourself, which one should I learn, UIKit or SwiftUI? You're going to have to know both. So in this course, we focus on UIKit for the most part, but I do have 2 videos towards the end of the course where I talk about, what SwiftUI even is, the paradigm shift, how it's different from UIKit, some of the benefits you get from SwiftUI, and then we're going to build a pretty basic screen in SwiftUI so you can get like a taste of how it works. But again, the entire goal of this course is to expose you to this world, give you that foundation of knowledge, so when you want to take your knowledge even further down one of these paths, you're doing it from a good foundation. So to sum that up real quick, you're going to have to learn both because we're way too early in SwiftUI's development for it to be relevant in the job market. And like I said, most of you watching this are going to be in the job market within a year. SwiftUI won't quite be ready. And even so, millions of apps are already in UIKit. So you're going to have to know that. It's going to be hard to avoid. So unfortunately, the answer is you got to learn both. And we're going to expose you to that in this course. All right, here's the updated October 2021 opinion on UIKit versus SwiftUI. Now, I left the old video in, maybe you just watched that, just to show the evolution of the thinking as time goes on, because that's been about 1.5 years since I recorded that one. And I said back then, in 2 years, maybe SwiftUI would be hitting its stride. And I do believe that's true with iOS 15. SwiftUI continues to grow and mature, and I think it's getting there. I think it's almost there. Not quite there yet, but it's really getting there. But aside from functionality and the ability to build a great app in SwiftUI, let's talk about job market relevance, because UIKit still dominates, I don't know the exact percentages, but it crushes it, right? Very small percentage of jobs are in SwiftUI relative to UIKit still, even as of October 2021. But it's starting to change. You're starting to see SwiftUI jobs pop up more and more. In fact, just last summer, I hired 2 iOS devs for a project that was completely SwiftUI. So again, you're starting to see it, slowly gain steam. But to be clear, UIKit still dominates as of right now. So my recommendation, if you're just watching iOS Dev Launchpad for the first time in October 2021 or later, you're just getting started, the recommendation on which to learn, which to focus on, I would still say you need to learn both, but again, SwiftUI is picking up steam. For example, in the old video, March of 2020, if you were going to focus all in on SwiftUI back then, I would have said that was a mistake. It's way too early. However, as of October 2021, I still think you need to learn both, but if someone came up to me and said, you know what, I'm going all in on SwiftUI, this is where Apple's going, right? The classic Wayne Gretzky saying, skate to where the puck is going, not to where it's been. I probably couldn't fault you for that. Because again, the process of going on this journey of becoming an iOS developer typically takes 6 months to 2 years. So if you won't even hit the job market for 6 months to even 2 more years from now, yeah, I think SwiftUI is gonna look a lot better. However, I would want to set your expectations that UIKit will still probably be dominant, so you are going to be limiting your job prospects, but it still may be the right move for the future. Quick example, that's what I did with Swift. Swift came out in 2014. It's about the time I started learning. And to be honest with you, Swift is what got me into iOS development. And I said that day, because it was the same situation, Objective-C was still dominant. No jobs were in Swift. But I said that. I was like, you know what? It's going to take me 2-3 years to be really good at this. So again, I want to go to where Apple's going. So I went all in on Swift, knowing that would limit my job prospects because Objective-C was everywhere. But, I worked at it for a year or so and finally got that Swift job. And I've been focused on Swift day one. And I think that was a good move. Here we are, 6-7 years later, and I've been writing Swift pretty much 100% from day one. So that has benefited me. So I think at this point in time, if you were to go all in on Swift UI, I think a similar thing might happen there. So again, to be clear, UIKit is still dominant as of now. It will still be dominant a year from now. But if you were to go all in on Swift UI, I couldn't fault you as long as you set your expectations. That it may be a little harder to find a job, but if you can find one, it'll really benefit you that you kind of made that gamble, that leap on Swift UI early. So there you go. That's the updated opinion. To sum it up, you still need to learn both. UIKit's still going to be dominant for a couple more years, but for those of you that like to be a little risky, like to take chances, I wouldn't fault you for going all in on Swift UI. But if you are more conservative, you are worried about landing a job right away, maybe you should focus on UIKit. Before we actually start writing Swift code, let's talk about what Swift is and give you a brief history, right? It's good to know what's going on with the language before you start learning. So Swift is relatively new. It was a surprise announcement at WWDC back in 2014. Like, developers had no clue it was coming. They're watching the announcements and it's like, holy crap, a whole new language? Like, everything changed back in 2014 when Swift was announced. What the engineers at Apple did was they took all their previous knowledge with Objective-C and everything, because Objective-C is 30 years old, and they did all their research on the new and modern languages and where things were going, and they took all that and they built Swift, Apple's next generation programming language that is for their future. Now, a lot of people always ask me, because native iOS development, admittedly, it is a niche programming language. It's not as widespread as, Java or JavaScript or Python. But it is niche, so a lot of people ask me, like, if I become an iOS developer, like, does that limit my career choices? And I always say, like, as a Swift developer, iOS developer, whatever you want to call it, you're tying your career to Apple. And as long as you believe that Apple's not going anywhere and it's going to be around for a long time, into AR, VR, whatever direction they go, I think that's a pretty safe bet. Speaking of safety, amazing segue, one of Swift's major selling points is it's just a safe language. There's type safety. Objects, can't be nil unless you use optional. Basically, a big thing of Swift is you want to have a lot of compile time errors, not runtime errors. As a new programmer, newly aspiring programmer, that may have meant nothing to you. Basically, what that means is Swift tends to give you errors at the time of writing your code or when the code compiles in Xcode, whereas runtime errors are you don't know about the error until the app crashes, and then you got to debug. So you're going to see a lot of compile time errors before you can even build your app with Swift. Let's run through Swift's very brief history. Again, it was announced in 2014, just to let you know kind of how Swift has evolved over the past couple years. Now, Swift had some massive changes and very rapidly in its early days. And the reason you should know this as a new beginning Swift developer is because if you look for a blog post or maybe a Stack Overflow answer or some resource that is old and hasn't been updated since, 2015, 2016, that can get you in a lot of trouble. Because again, through 2014, 15, 16, 17, Swift has changed a lot. But the good news is that change is starting to slow and Swift is slowly starting to mature. All right, back to the beginning. Like I said before, it was a surprise announcement in 2014. By 2015, Swift 2.0 was announced, and it was also announced at WWDC in 2015 that Swift was going to go open source later that year. It ended up going open source in Swift 2.2 later, like in December of 2015. Now, open source was a big deal because that meant the iOS developer community as a whole could contribute to Swift language itself. If you ever want to look into this, go to swift.org. You can see the forums and see the discussions on proposals that are going to be implemented into Swift. Now, don't get me wrong, this is like heavy language implementation details. Most of it's even over my head. But if you are interested in like how the language gets built or, what new things are coming to the language, that's the spot to go look. Now, going open source was a big deal. But in 2016, Swift 3 came out, and that was a huge deal. That was dubbed the Great Renaming, Basically, what happened between Swift 2 and Swift 3 was a ton of breaking changes in Swift's API. So it was a nightmare converting a Swift 2 codebase to a Swift 3 codebase because so much broke and so much changed. However, Swift 2 to Swift 3 was kind of like just ripping off the Band-Aid, right? It was a ton of pain right there, but Swift 3 to Swift 4, Swift 4 to Swift 5, and upcoming Swift 5 to Swift 6 have been a breeze compared to that. So they kind of got all the pain out of the way going from Swift 2 to Swift 3. So again, when you're looking at old resources or old blog posts, if it was done in Swift 2, stay away from it. But like I said, after that major Swift 3 pain, it's been smooth sailing since then. Swift 4 came out in 2017, but Swift 4 kind of was the last major number release at WWDC. Up until Swift 4, again, every dub, which was June of every year, we would get a new Swift 3, Swift 4. Well, they've kind of slowed down since then, and WWDC 2018 was Swift 4.2. It has slowed down, and they recently announced on the roadmap to Swift 6 that, there's no major year release. It's just going to release when it's ready, which is great. I love that because it almost felt like they were rushing features into the language to make the annual release cycle. And, they've kind of learned and said, you know what, Swift 6 will release when it's ready, no release date, it'll come. Again, that along with the fact that, the changes coming aren't major breaking changes shows that the language is maturing. And because the language is maturing, we're starting to see it leak out into non-Apple native platforms. For example, machine learning at Google via TensorFlow, that is done in Swift now. That's in part to Chris Lattner, who is one of the main developers behind creating and launching Swift at Apple. He had left for Google and brought Swift over to TensorFlow. He has since left Google as well, just recently, but he was spearheading Swift at Google as well. So it got a good foundation over there. And now you can also write server code in Swift. Swift is almost ready for Windows. That's being actively worked on. But again, Swift is such a young language that, it may not be on all these other platforms yet, but you can start to see the beginnings of it. And if you kind of fast forward your mind 5 to 10 years, it's looking pretty good. Now we're about to go into a bunch of videos about the basics of the Swift language. I want to reiterate that these are just high-level videos, right? A lot of these topics could be almost whole courses in and of themselves, or at least multiple 10, 15-minute videos. Again, like I said before, this is supposed to be your first video, just your exposure to this world. So again, these topics will be pretty high level, but it is a good foundation for your future learning. Speaking of future learning, I want to recommend a couple resources for you to check out to, again, just expand your world of Swift. First is the Swift Programming Language book directly from Apple. A little bit of a warning, and we're going to talk about this later in the books video, but this is basically Apple's instruction booklet for Swift. So it is pretty technical. I remember reading it as somebody who had never coded before and just started my Swift journey, which may be exactly where some of you are at. It was way over my head, but it is a very valuable piece of information. So I do recommend at least checking it out. But again, don't get discouraged if you don't get any of it. It's a pretty technical book for beginners. What is geared towards beginners is the Swift Playgrounds app. And I definitely recommend downloading that. It's free to download. It came out a couple years ago, and it's being actively maintained. Like every year or so, you'll see a pretty big update to the app that adds a bunch of new features. So that app is still growing, but that's a great way to get started and play around as well. They do a good job of gamifying things. And in the description of this video, I'm going to leave 2 more links. One is to the actual Swift website page if you want to check that out for another big overview. And then another is a pretty fun video about the reveal of Swift at WWDC in 2014. And you can hear the gasps in the audience. It's pretty cool to go back and watch. So that's a brief history of Swift. Let's start writing some code. Let's talk about a foundational concept in Swift, and that is types. What is a type? It's what type something is. Great explanation, I know. Let me show you and that'll make more sense. In this example, we're talking about the type int, which is short for integer, which is a whole number. Now it can be negative, but an example of that is, let's say you have a high score in a video game. So we're going to create a variable called high score. It is of type int and it equals 0, right? We're not very good at the game. But the type is int. So what we're saying is this 0 is an integer. Now in Swift, there's tons of different types. We're going to talk about the foundational ones in this video, but the general idea is that our variable high score is of type int and it is equal to 0, which 0 is an integer. Let's build upon that numerical example and talk about our next two types, and that is float and double. Whereas if integer was a whole number, float and doubles are decimals. Now the main difference you need to know between float and double is the amount of decimal places, or the precision. A double has a precision of at least 15 decimal places, so pretty long, whereas a float has a precision of at least 6 decimal places. So as you can tell, a double is more precise than a float. And now with these floats and doubles, you don't have to use all these decimal places. That's just their capabilities. As you'll see in this example of a percentage complete, like we want 76%, so we'll just do 0.76, right? You don't have to use all those decimals. 0.76 gets the message across. But to reiterate, here we have our variable called percentage complete, and that is of type double, and it equals 0.76. Moving away from our numerical examples, we have string. Now a string represents text, and in declaring a string, you put it in quotation marks like you see here. Let's look at an example. We'll create a variable called user's thoughts, and that is going to equal, I hope this course is good, right? So that is a string. Another example could be, my name equals Sean, as you see here. So that is of type string. And finally, we have our bool type, which is short for Boolean, and that is just true or false. In the example here, you can see we have our variable is dark mode on, and that equals true. I know I ran through these quickly, but this is the foundational knowledge that we're going to use and explain throughout the entire course. So you're going to have plenty of time to reinforce this knowledge. But I want to leave you with two pieces of information before we leave the video on types, and that is that, like I said, there are tons of different types throughout Swift, and often we even create our own types when we create classes. So let's say we create a class that is a person, right? You can see Sean is of type person, and then you create that person object. More on that later in the course, but that's just an example of how it doesn't always have to be an int, a Boolean, right? You can create your own custom types. And then lastly, a big feature of Swift is type inference, right? So back to our high score example. If I do var high score equals 0, Swift is smart enough to know that because I put a 0 there, not 0.76 or 1.89, it's a 0, Swift is smart enough to infer that, okay, this is an int or an integer. We don't need to declare the type. And I would say 95% of the time, type inference will work perfectly fine. There's a small subset of time where you will have to manually declare your type. But again, type inference works most of the time. So in future lessons or videos, if you don't see me declare the type after my variable, again, var my name is of type string equals Sean. If I just remove the is of type string, that's type inference at work. So hopefully that avoids confusion. But again, that's the basic knowledge of types. We're going to use this all throughout the course, so you'll have plenty of practice with it. Variables and constants. We got a little bit of a sneak peek in this in the previous video when I was showing you how to use types and I was declaring variables. So you may have a little bit of an idea, but let's dive into that a little further. What variables and constants do is they capture a value so you can use that value throughout your code base. Right back to the previous example talking about integers when we said var high score of type int equals 0, we're capturing the value of 0 and now it's in a variable called high score. Now we can use high score throughout our code base. So again, the fundamental knowledge is variables and constants capture a value. Now, what's the difference between a variable and a constant? Well, a variable has the ability to be mutated or changed, whereas a constant cannot be mutated or changed. And there's some pros and cons to both, right? So if you make something a constant, it's a little bit of a safety feature to where you can't accidentally change it when you don't mean to. Xcode will yell at you. And then also there's a little bit of a performance optimization because Xcode, if something can be changed, it has to allot for that possibility. Whereas with a constant, you say, no, this is the value. It is not changing. Xcode can optimize that and your code can run faster. Now in this first lesson, I'm going to show you how to open up a playground and set everything up. But on future lessons, we're just going to skip this step. So here, get started with a playground. Click on that. Let's start with a blank one. So hit next. And I'm going to name it beg-variables. And I'm prefixing all my stuff with beg because that's how I'm organizing my files all around the beginner course. You can name it whatever you like. And I'm saving that to my desktop for now. And let's make Xcode fill up the whole screen for you. There we go. And your playgrounds will automatically start with a variable that says hello playground. That's a string. Remember we talked about this in the previous video. So just a real quick example. This is a variable called str that is type inference to be type string because Xcode knows this is a string. All your playgrounds automatically start with that. let's delete this. Don't get ahead of me, Xcode. All right, so let's talk about variables versus constants. Let's continue with that high score example. So var high score equals 0. And again, type inference on the end. I don't have to say it. So now I can actually change high score. So I can say high score equals 55, right? I can update my high score. I did really good on the game, updated my high score. The reason I can change that is because we declared it with a var, so it's a variable. Now, if I made this a let, which is a constant, so if you want to declare a constant instead of var, you do let. Now, if I run it, you'll see it's going to say, cannot assign to value, high score is a let constant. So, but like I said, if it's a let, Xcode will say, no, you can't change this. If it's a var, you can change it. And real quick, just to avoid any potential confusion, when developers are discussing code, and you may hear me say this throughout the course, is oftentimes they'll just call these all variables, whether it's a let or a var. You may not distinguish between the two, right? Oftentimes you just say, create a variable for that and do this with it. And that's because when discussing code, you may not know all the specific implementation details, if it needs to be a let or a var. So if I say, hey, we're going to declare a variable here, I'm not always saying it has to be var, right? It could be let. So variable is kind of like the overarching, way to refer to it. And then deeper, the difference between let and var depends on your implementation details. So again, to avoid any future confusion, if I call something a variable, but I make it a let, that's why. But again, the textbook answer, right? So somebody could come up and correct you because technically they would be correct. You should call it a constant or a variable. But again, oftentimes in just common conversation, we just call them variables. So hopefully that avoids future confusion. All right, let's change this back to var and let's give 2 more examples to just really drive this point home. So something like a name of a person, right? You don't want to change that. So you would do something like let my name equals, and this is a string here, Sean. So now I can't just do my name equals, Joe, right? It'll yell at me, right? Because my name is a let. Cannot assign value to my name. It is a let constant. But something, let's delete this, more along the lines of, var current active users, right? That's something that is always fluctuating. We'll say that equals 124. Now I can change and update that, right? Like say I get a huge spike in traffic on my app. I can, say, okay, we need to set current active users equal to 1,458, right? And that can be changed because that is a var. And to reinforce the core concept of variables and constants, they capture a value. So you can use that value, for example, this current active users value, I can use that throughout my code base. For example, if current active users is less than 4, print out traffic is way down, right? I can do stuff like that based on the value that's captured in this variable. Now let's talk about arrays. An array is a container or a list of objects. Here on the screen is a visual aid to hopefully help you understand the concept of an array. For example, this would be an array called fruits. As you can see, there's various different fruits in this list. Now, one key thing to know about arrays is that this list is numbered, but as you noticed, it's 0 indexed. What that means is the count starts at 0. So the first item is not 1, it's 0, right? As you can see, 0, 1, 2, 3, 4, 5, not 1, 2, 3, 4, 5. Real quick, take a second to let that sink in because I guarantee you're going to have an error because you forgot this at some point early in your career. So this is very important. It's a fundamental thing to know about arrays. Now, of course, arrays don't always have to be fruit, right? We can have an array of integers, right? Let's say we want to call this ages, and this represents the age of everybody currently taking this course. Another thing to know about arrays is that they're always in order. Now, by in order, I don't mean alphabetical. I don't mean numerical, as you can see with these different ages, right? I mean the order that they were put into the array. Let's illustrate that and a lot of other things you can do with an array in some code. Here I am in a brand new playground. Remember last video I said I wasn't going to go through the step every time of like file new playground and naming it. So go ahead and do that on your own and you'll see this empty playground to start with. All right, so let's create that array. So var ages equals, and it's an array of, let's say, the different ages, 21, comma space 55, comma 19. I'm just going to put in like 8 of these real quick, just random numbers, and whatever, 71, that's it. I think there's, 8 of these in here? Cool. Now, real quick, we just declared this array, and what I talked about was the order that I put them in. So, I put in 21 first, then 55, then 19. That's what I meant, that they will always be in order. Again, not numerical order. And again, back to type inference, ages knows that it is an array of ints because I've put all ints in here. Now, however, let's cut these. I'm going to do Command X to get rid of them because I'm going to paste them back in so I don't have to type them again. Now I have an empty array, but you'll see Xcode is saying empty collection literal requires an explicit type. when I had all integers in there, Xcode knew, all right, ages is an array of ints, but I don't have anything in there, so it doesn't know. When you want an empty array, which is actually quite common, very often you'll declare an empty array, but if you do that, you have to give it a type, and you have to put the type in the brackets to let it know it's an array. So this is saying ages is an array of type ints. So that way, even if you declare an empty array, Xcode knows, hey, I'm expecting an array of ints. And then later on, if you try to put in a string or a Boolean, Xcode's gonna be like, no, can't do that. This is an array of ints. But let's put those ages back in there, and we can delete our type declaration because we don't need that. We'll use the type inference. Now let's talk about some of the features of an array and how you can use it. So first up, we can always get the count of an array by doing ages.count. And this gives you the number of items in the array. So if I hit this little play button on the left to run it, you'll see on the right, we printed out 8. So that means there's 8 items in this array, and you can count it for yourself. There are in fact 8 ages in there. Another common thing you want to do with arrays is access the elements that are in there. For example, you can do ages.first, and this will return the first item in this array, 21. You can see it print out 21 here. 21 is the first age. Same thing, you can do ages.last. Same thing. Now it's going to give me 71, right? As you can see right there, because that is the last element of the array. Now, real quick, a little sneak peek into optionals. You'll notice ages.last was an optional. This question mark means it's an optional. We're going to dive into that later. I'm not going to get into that now because we're just starting out. But the reason it returns an optional is because ages could be an empty array. And if you have an empty array, what's the last object in an empty array? Like nothing. So you don't want the app to crash. So that means it returns an optional, which means it can be nil. Again, if that was confusing, you don't know what I'm talking about, we're going to discuss that in a later video. But I wanted to explain to you what this little question mark meant. That basically meant that like this can be nil. This can have no value. And again, in the case of an empty array, there's no last object in an empty array. All right, more accessing items in the array. So we did first, we did last. What if you want one in between? We can do ages, and this is called subscripting. We do brackets and then put in a 0. This is where you put in the index number. So ages at index 0 is going to be 21. So it's going to be the same as first because we did index 0. You see it prints off 21 there. But you can also do, the fourth one if you want for 3. Remember, 0 indexed. So the fourth item is going to be 3 because it goes 0, 1, 2, 3. So now the fourth item is 47. See, it prints off 47. So that is how you can access individual elements in the array. And again, this goes back to the array being ordered. It's always going to be in the order you put it in. That way you can reliably say, give me the item at index 3, and it's always going to be the same. If it was not ordered, item at index 3, it would be different every time. So that is why the array is ordered. Now, aside from accessing items in the array, we can actually manipulate our array. Let's say we got a new student and we wanted to add a new age to the end of it. So I can do ages.append, and you can see new element int. And this is type safety in action, right? Because ages is an array of ints, it's not going to let me put anything other than an int in there. Again, this is the whole safety aspect of the Swift language. So let's say we want to put 99 in there for our new student. Now, a way to print out stuff is to print ages. And if I run it down here in the console at the bottom, it's going to print out my ages. And now you can see 99 is now appended. So the thing when you append stuff is you're appending it to the end of the array. So that's why 99 went there. And let's say you didn't want to append it to the end, you wanted to put it at a specific spot, you can do ages.insert, and you can see new element, which is an int, again, type safety. So let's say we want to put 44 at, and now we're putting an index, right? We want to put it at index, let's say 0. We want to put it at the beginning. So insert 44 at index 0 right at the beginning. Now if I run it, we're going to print ages down here, and now you can see 21 is no longer at the beginning, 44 is at the beginning. And the last 3 things I want to show you is how we can sort our array, how we can reverse our array, and how we can shuffle it, right? So let's do that. So ages.sort, and you can see if we print it, now we're going to get this array in numerical order, right? 19, 21, 22, 37. So sorting an array is as simple as that. And we can do the same thing to reverse our array. So if we do ages.reverse, there you go, and we run it. Now, we didn't do sort anymore, so it's going to reverse what's actually in there on line 3. Or actually, no, we added the 44. So 44 is at the end, 21, 55. You can see it's in reverse order from what we have up here. And then, as you may be following along here, we can do shuffle as well. Shuffle. And that will shuffle up all the numbers in the array. So you see, we got the array down there, and now it's all shuffled. So those are some basic things you can do with an array. Now, arrays are used so much throughout code and building apps. A very common thing that you may see on a day-to-day basis is maybe your Twitter feed, right? Your Twitter feed that you're scrolling through is an array of tweets. It's just a list of tweets that show up on your screen. And same thing with your Instagram feed. Your Instagram feed is an array of posts that show up on your screen. So arrays are used everywhere. It's a very foundational knowledge. Hope you got that. As always, ask questions in the comments or on the Slack channel. On to the next video. Let's talk about sets. Now, a set is pretty similar to an array in that it is a collection of items. However, there's some key differences between sets and arrays. First up, a set is unordered. If you remember last video, we talked about arrays being ordered and they would always stay in the same order, provided you don't change them. Well, a set cannot guarantee any order. Next, a set cannot have duplicate values. If you remember the array that had all of our ages from the students in the course, well, in an array, we can have duplicate values in there. However, a set can only have one of those values, no duplicates. So you may be thinking, a set is not ordered, I can't have duplicates, like why would I want to use a set? Well, one big advantage to a set over an array is performance and speed. Sets have faster insertion, removal, and lookup. And to illustrate all these points, let's dive into some code. Here I am in an empty playground. Go ahead and create that on your own. To start, we're going to recreate that array, not a set, our array of ages, because we're going to use this as comparison to help really illustrate the differences in a set. So I'm going to throw in a few random ages in here, 18, 33, 55, 17, 94, 20, 26. Okay, cool. Just some random ages. And actually, let's put some duplicates in here just to illustrate that we can have duplicates. Space 17, right? So you see 17 is a duplicate and 33 is a duplicate. That's fine in ages. So again, we're going to use this array to learn about sets. Now to initialize an empty set is a little bit different. So you have to do ages. Let's call this ages set just to be clear here. And for the array, if you remember, we would do this for the array. So we would say it is an array of ints when we were declaring a type. Well, for a set, you got to be a little bit different. You have to say it's a set and then you use angle brackets and you put the type in the angle brackets. So equals that. So now that is an empty set, right? We've declared here, this is a set of type ints. That's if you want it to be empty. You can also initialize a set based on an existing array. So that's what we're going to do down here. So var ages set. Now I can't have two things of the same name. So let's comment this out. You can do command / to comment that out. So ages set. And now we can initialize this based on an array. So we can do set and then we can pass in an array. So we can do ages, right? So you can create a set based on an array that already exists. This ages array already exists up here. Now, if you remember, I said you can't have duplicates and it's unordered. So what we're going to do is we're going to go ahead and print ages set, and then you're going to see that our duplicates aren't in there, right? If you look here, we have 17, 17, 33, 33, right? We're not going to have those duplicates. So let's go ahead and print ages set, print ages set, run it. And down here, I'm going to move this up. See, we don't have a duplicate of 17. We don't have a duplicate of 33. And if you look, it's not really in the order that we have. It's actually kind of close, so I can see where you might confuse that, but it's not in any order. If I run this again, we're going to get a different order. Just pay attention. It's 18, 17, 55. So run it again. Well, let's stop it. Run it again. See, now we got 55, 26, 33. So again, order is not guaranteed. You can't have duplicates. So again, back to the question, why would you use a set? Well, it's because of performance. Again, like I said, the set has very fast insertion, very fast lookup, very fast deletion. And the reason being is because in order for something to go into a set, it has to conform to hashable. Stick with me. I know as an absolute beginner talking about hashable and hash values and constant time lookup, that is getting a little bit excessive. I understand that, but I can explain it pretty simply. Now, conforming to hashable is a requirement to go into a set. Now, luckily, the basic types that come with Swift that we talked about, string, int, boolean, double, float, those all automatically conform to hashable. So this is really only going to come into play when you're creating your own types, right? Like we created our person type. Remember that example? Person with the name Sean. That's not going to conform to hashable unless we actually implement that ourselves. So until you're building your own custom objects and custom types, pretty much everything is going to conform to hashable. So don't worry about that too much. Again, as long as you're using int, double, bool, string, which is what you'll be using most of the time. Now, by conforming to hashable, what that means is that it just has a hash value that is an identifier. Again, I'm putting this super simply. Think of a hash value as like a direct pointer to that location. Let me do an example to illustrate that. So here, back in our code, we can do the contains function here. So we can do ages set dot contains, right? And you can see the member is an int, right? Because this is a set of ints. So I want to see if it contains a certain number. So by doing 17, it can look right for 17. That's constant time lookup. Whereas, array also has a contains function. However, what an array has to do, and this is why a set is faster, an array would have to check the whole array. So if I was looking for 17 in the array of ages up here on line 3, what the array does is it's going to check here. It'd be like 18. Nope, that's not 17. It'll check 33. Nope. Okay, it'll check 55. It'll check 17. Okay, cool. Now, in an array of 8 items, no big deal. But you can imagine, if you're storing data, you can have an array of, 1,000, 2,000, a lot of numbers, items. So that's where the performance comes in, where, again, the array has to look through the entire array until it finds the number. Whereas a set, because of the hash value, can go right to that number. And that's called constant time lookup. Basically what that means is the time to look it up will stay the same no matter how big the collection gets, right? So if our set, it has 1 million items in it, the time to find 17 is going to be the same exact time as if our set had 10 items in it. Whereas the array is different, right? If the array has 10 items, okay, that's going to happen pretty quick. It only has to check 10 items. If the array has 1 million items, now it's not going to be as quick because it has to check through 1 million items. So hopefully you're starting to see the performance of a set. But again, it's a trade-off, right? A set gets that performance because they don't guarantee an order and they can't have duplicates. So that's the trade-off. They trade those features for performance. Whereas an array, you can't have duplicates. It's always going to be in the same order, but it's a little less performant. And that's actually a good analogy for programming in general. You'll find as you go throughout your career when you're making decisions on what to use, it's all about managing the trade-offs, right? Every approach in implementation has pros and cons, and it's all about choosing the right tool for the right job based on those pros and cons. So let's run this and you should see it'll print true here over on the right. Yep, true, because it does contain 17. Now if I want to say, does it contain 100, which we know it doesn't, or 101, my finger slipped, it'll come back and print false, because it does not have 100 in there. So that's how you can see if your set contains a value. Now let's talk about inserting a value into our set. If you remember on our array, we use .append, and that tacked it on to the end of it because it keeps the order the same. However, sets don't have an append, right? We just insert it into the set. It's kind of like throwing it into a bucket. Like, we don't care about the order, mix it up, who cares? We're just throwing it into that bucket. And again, that's the whole, very fast insertion or deletion. I don't have to pick where exactly I want to put it. We're just putting it in the bucket with everything else. And to do that, you can do ages set.insert new member. And you can see let's insert that 101 that we put up there. And because the code runs down the line here, let's cut this and put this up here. So that way we're inserting 101 into our set, and then we're going to check to see if it contains it. And now you can see down in the printout, I got confused because we didn't have a 101 down here in the printout. That's because I printed it before we added it. Again, the order you put things in matters. So hopefully that's another little bonus lesson that I didn't intend on. But now we're going to print ages set down here. Now 101 should pop up in the set. There it is. So it got inserted. And then let's check our contains 101. That is true. So again, to reiterate, the main differences between sets and arrays, even though they're very similar because they're a collection of items, is that sets are unordered, arrays are ordered. Arrays can have duplicates, sets can't have duplicates, and sets have faster, insertion, removal, lookups because of the hash value requirement. And again, it gets that performance boost because of the trade-off of no duplicate values and not having to worry about order. So that wraps up the basics of a set. On to the next collection type, and that is dictionaries. Our third collection type that we're going to discuss is a dictionary. And just like a set and an array, it is a collection of items, except this collection of items